I'm Greta. Let's talk about machine learning for manufacturing. The terms supervised learning and unsupervised learning are often used when we talk about machine learning. These two learning styles describe the different algorithms we can use to solve machine learning problems. The style that you use depends on the data that you have and the problem you're trying to solve. So what's the difference? Supervised learning uses labeled data to solve classification or regression problems that have a well-defined failure mode or threshold for failure. Let's say you want your model to distinguish between defective and non-defective transmissions. By showing the model historical data, you can teach it what a defective transmission looks like so that it can recognize when a new unit is defective. The labels tell the model what counts as defective and non-defective so that it can classify new transmissions into one of those categories. This is an example of classification problem. You can also use supervised learning for regression problems that have numerical solutions, like predicting frequencies for NVH testing. In contrast to supervised learning, unsupervised learning uses unlabeled data to solve clustering or dimensionality reduction problems. Unsupervised models are able to group data points and features without being told what to look for. Although there's no specific target to predict, the model is able to map the underlying structure of a dataset. It can't tell you which units passed or which ones failed at the end of the test, but it can group those units according to their similarities and separate them by their differences. Clustering problems involve grouping data points to detect anomalies in the data. That includes hierarchical methods, which group the closest data points together, or density-based methods, such as db-scan clustering, which groups high-density points together. Dimensionality reduction combines similar features, which makes data easier to process by reducing the number of groups. For example, you might combine the frequency and amplitude of a signal into one group. In some cases, you can actually use clustering and dimensionality reductions together, condensing the number of data points and the number of features at the same time. In addition to supervised and unsupervised learning, there's also semi-supervised learning, where only one feature is labeled. For example, if you only label engine misfires, but no other failure modes, you would only be able to train the model on engines that misfire and classify engines as either misfiring or not. Using the right set of machine learning algorithms is crucial to getting the most from your data. This is why it's important to analyze your manufacturing dataset and your goals before you build your machine learning models, which we'll talk about more in the next video. Thanks for watching. And if you'd like more information on supervised and unsupervised learning models, check out the links in the description below for some great articles that address them in more depth.